asking you about a painting in science class?
Because you're out of ideas.
Because I'm out of ideas. That's funny. No! It's because I want you guys to get a little more comfortable with this process of claim evidence reasoning, because I think there's like this stifling like shroud of mystery around CERs because we do the ACE format, you know, and everybody gets real nervous when we start talking about writing statements. So the CER statement though, guys, is just a way for us to write a scientific explanation. It's like an outline, okay? It makes your job easier. It's not supposed to make it more difficult. So we're decontextualizing it. We're taking it away from science, and I want you guys to think about answering a question in a different form, okay? So who can tell me, no wrong answers here, what's the meaning of this picture? Yeah, Billy?
Properties.
Can you explain that a little bit more?
So it basically describes the object by what you can observe from it.
Okay, so the meaning of this picture or the topic of this picture is like it's showing different properties of the objects in it, okay? So how can we word that? What is the meaning of this picture? Each object has different properties. Or each object present, maybe? I don't know, that's fine. Has different properties. Other answers. No wrong answers, guys. What's the meaning of this painting? Or what's the subject of the painting? Or when you look at this painting, what does it make you think? Yeah, thank you.
Personally, I thought it was December because of the dying trees and all the leaves.
Okay, so we're going to cut off the because part there because you're going to use that later. And we're going to say the subject of this painting is, did you say December?
Yeah.
Awesome. I love it. Okay. Any other explanations, rationales for what the meaning of this picture is or what the subject of this picture is? Yeah, Max? I'm sorry? I still didn't hear. I'm sorry. What we use. So things that we use. So this picture shows what we use. Okay? Guess what, guys? You just made a claim. So our driving question for our bell ringer here, what is the meaning of this picture or what is the subject of this picture? And you guys just gave me a claim. A claim answers the question. Is a statement about whatever question we had. In science, it could be a statement about a question that we had that we'd used a investigation to figure out some data and collect data to answer, right? Now, our evidence. Evidence is like the cold, hard facts. It's just our observations, right? So what are some things that we observed in this picture? Huh? Come on, no wrong answers. Don't worry, they can't see you. They can only see me. Go ahead.
Flowers? No, that would be.
What do you see?
Max.
Tree. Tree. Okay, Max, what do you see?
I see leaves.
Stars?
No.
So we have trees present. We've got leaves present. We've got stars present.
Got dog there.
A dog?
Leaf? Yeah. And a whale.
Dog present. Billy, what's some of the stuff that you saw?
I observed that they all have different shapes and forms.
All right, let's be specific.
The blue ball shaped like a round.
Okay, so blue ball present. Red cup present. Green stairs.
I'm guessing that's an almond.
What?
On the chocolate almond.
What's that?
Right underneath the tree.
Okay. dying tree. Max, what do you got?
A man walking with a cane.
Okay. Man with cane.
He's old.
Mia, what do you got?
I was gonna call that oatmeal, but you called it a red cup, so.
What'd you call it? Oatmeal?
Yeah.
Hey, it's fine. Oatmeal and bowl. Anything else? Yeah.
Could we make like an assumption that the man with the cane is old?
At this point, we're observation. So can you see that he is old?
No.
Not necessarily. Okay, so we're just doing our observations. We're just doing straight evidence. Guys, in your claim evidence reasoning statements, your evidence does not have to be in a complete sentence. It can be in bullets like this. It could be in the form of a data table, which in science a lot of times it will be, right? It could be in the form of a graph. It could be anything that you're collecting data for to answer your question, okay? So here we go. This is our evidence. Now, our reasoning is what ties our claim and our evidence together, okay? So let's pick a claim, and then we're going to select pieces of evidence that support our claim, and we're going to use reasoning to explain how it supports our claim, okay? If you guys look back here, this graph or this chart, you have it in your digital interactive notebook as well in resources. There's some sentence starters for reasoning that might help you wrap your brain a little bit around it. So you are taking your evidence and you're connecting it to your claim. So your piece of evidence would be like, I see blue objects, red objects, and green objects present. So that's your piece of evidence. That supports your claim because, and then you tell us why it supports your claim. Okay? So let's start out with Billy's claim. So we know that what are some principles that we can apply to properties? Like, what do you guys know about properties? Why do we use properties? Okay. All right. So properties. All right. I'm going to turn off this part of it so that I can use more of the board to write. Okay. So we've got our claim over here. We've got evidence here. Now we're going to connect them together using reasoning. Okay? So, properties of matter are what? What'd you say, Cheyenne? Why do we use properties? Okay. So we can do something like, we use properties of matter to describe objects. What are some examples? What are some different properties? Huh? What? Shapes?
Looks.
Looks. Okay, so can we be more specific? State of matter, okay. You said looks, we could say like shape, something like that. Okay, so this is our scientific principle or our like general statement that we're going to use to draw these two things in together. So Billy says that each of the objects present has different properties. So the topic of the subject of the painting is to show different properties of different objects, right? So what in our evidence can we tie in here? We might not use all of the evidence that we've gathered, but there should be some evidence here that demonstrate that each of the objects have different properties. Does this tell us anything about the properties of the object? No. Does this? No. Does this? No. Does this? Okay, this one tells us something about a property. How about this one? Yeah. How about this one? Yeah. How about any of these? Okay. Which one? Remember, we're trying to collect evidence that supports that each object has different properties. Okay, maybe this one is dying. Dying being a property. Okay, so let's select these here. We've got each object present has different properties. We use properties of matter to describe objects. Examples include color, state of matter, looks, or shape. What are we observing here? So what's our evidence? We observe objects that are what? Blue.
Red.
Uh-huh. Blue.
Purple.
Red.
Purple.
Is there a purple thing?
No.
No. Blue, red, and green. Right?
Pink? No. Yes. There wasn't anything.
Is there something that's pink?
Yeah?
Okay, well you can include whatever colors that you observed here, right? As long as it's in your evidence. We observe objects that are blue, red, pink, and green. And that supports our claim, right? By showing different what? Different properties, right? Does that make sense, guys? So you're connecting your evidence here to your claim using reasoning. We use properties of matter to describe objects. Some examples are color, state of matter, the way something looks or its shape. So we observe, or our evidence shows, you can say that too. Evidence shows objects that are blue, red, pink, and green, which supports our claim by showing different properties. Helps if I can spell correctly. Right? What are some other properties that we noticed that are different? Is there anything else that we want to tie in? Yeah.
Shape.
Shape. Okay. So we have to add to our list here. We've got stars. We have dog shapes. We have leaves, trees. So evidence shows the presence of stars, circles. We talked about balls, cups, stairs. Those are all different shapes, right? Shape is a property. Therefore, it supports our claim because it's showing different shapes. We observe different shapes. Does that make sense, guys? Okay. How would we reason our claim that the subject of the painting is December? We got our same evidence here, but this time we're defending that the painting is about December. What do we need to know about December? Okay, December is cold. What else? Huh?
Trees die.
Okay. Trees die. Anything else happen in December?
No.
Cold?
It looks to snow.
Okay. All right. So we're applying our principle or our scientific principle. We're defining something in our claim, right? So December is cold, trees die, and it snows. Now, what can we pull from our evidence that connects our claim to this, or what can we pull from evidence that will connect our claim, that will defend our claim? So what does evidence show? What you got, Cole? Okay. Which of these tell us that it's December?
The dying tree.
Okay. Evidence shows a dying tree. Right? supports the claim because in December plants die, or something like that, right? So you've got your evidence, you've got your claim. Your claim is that it's showing us December, and you're connecting them by explaining that in December, what happens? Plants die, right? Okay. Anything else here that tells us it's December? Yeah.
Leaves present.
Okay. Leaves. Evidence shows leaves fallen from the tree, something like that. This supports our claim because why?
Because when leaves fall from the trees, it has to be cold outside.
Okay. Because when it gets cold, leaves fall from trees. Something like that. Okay? Do you guys see the connection there? You're observing things, you're collecting evidence, and you're connecting your claim and your evidence together using reasoning. Good? All right. We do this in science all the time. In fact, this is how we come up with scientific investigations, right? We start out with a question. Can we support life on the moon? What kind of evidence can we collect? What do we need to know if we can, in order to answer that question? Yeah, Wilton?
Maybe we can leave on there and grow food.
Okay, can we grow food? Good, yeah.
There's a substantial amount of resources that people need to survive there.
Okay, is there enough resources that we need to survive there? What evidence do we have? What did we just observe on the moon?
Oh, water.
Yeah, water, right? So we could use that evidence that we collected to answer our question. Will the moon support life? We observed that there is water on the moon. We could potentially use that water in order to grow food and in order to support life, right? So that's our reasoning. We pulled the evidence that we have and connected to our claim. Our claim is an answer. Can we support life on the moon? Yes, we can support life on the moon because there is water on the moon and we need water in order to support life. Easy peasy, right? Okay. Go ahead and open up your CER from yesterday and we're going to finish that. All right, so you guys may have remembered over the last couple of days we've been doing a lab, right? We've been gathering evidence. What evidence have we been gathering? Peyton, are you raising your hand? No. What have we been looking at, guys? What have we been comparing and contrasting? Yes, we've been looking at rocks. Absolutely. What are we looking at rocks for? Okay, we've been observing their physical properties and comparing them with the physical properties of what?
Each other.
The elements that make them up, right? So we've been looking at minerals, which are compounds. Those compounds are made of elements that undergo a chemical reaction, right? We look at the physical properties of the compound, and then we look at the physical properties of the elements that make up that compound, and we're looking for similarities or differences. Why would we be looking for similarities or differences? What does it show us evidence of? Yeah.
Chemical change.
Yeah, chemical change, right? So a chemical reaction happens when the atoms that are inside of a molecule pull apart and then reconfigure themselves, rearrange themselves to form a new substance, right? That's the definition of a chemical reaction. And so in order to see evidence that a chemical reaction has occurred, we're looking for a change in those physical properties of what we started with compared to what we end up with. Does that make sense? Yes? Okay. So, our CER statement, I know we got started on this yesterday, right? Yes? Okay, can everybody open it up in Google Classroom? So, our question here, let's see. We've got silicon and oxygen are combined under certain conditions, quartz crystals form. Is this a physical or chemical change? So there's our question. Use your scientific reasoning skills to justify your claim. All right. So for our claim, what do we need to do? We need to answer the question, right? So what are our two possible answers for this question? Yeah, Max?
Chemical reaction or chemical change or a physical change.
Right, so either this is a chemical change or this is a physical change. There are two possible answers, so we're going to pick one. Which one do you think we should pick? Hmm? Chemical. When silicon and oxygen combine to form quartz, a chemical change has occurred or takes place or something like that, right? That's your answer. That's a statement, right? There is no I think, there is no I believe, there is nothing like that. It is just a statement. It is an answer to the question, plain and simple. Okay? Now, what kind of evidence do we need in order to defend this? What evidence did we gain? What kind of observations did we make, guys? Here. Do you need me to pass back your papers? I'll pass back the papers. Okay? The color? Boiling and melting point, odor.
Odor.
Okay.
Thing.
Odor is what something smells like, right?
Yeah, those not.
All right. So just like with our last CER that we were doing, we don't necessarily need to have complete sentences for our claim. If you have the ability to insert a data table, you could insert that entire table that is for quartz, right? Because it shows all of the properties that we observed in quartz and in the two elements that make up quartz. Hello? Hi. I sure can. Uh-huh. Woo. Brennan, can you go see Mr. Noble, please? Okay, hi. Kylie. All right, so if we had the ability, we could just copy and paste that table straight from your lab into our claim evidence reasoning. However, we do not have that ability, so we're actually going to have to put in some data. Right? So you've got quartz on the back of your first page. Right? And we've got silicon and oxygen that make it up, right? You could make your own table if you want to get fancy. Okay? So, our data includes the, what did you guys tell me? State of matter?
Color,
Color,
odor,
odor,
melting or freezing point.
melting point. That's it. No, density. Right? So, what state of matter is quartz in?
Olive.
How about silicon? Oxygen. Do you guys know how to insert a table into your Google Doc?
Yeah.
No.
No?
Yeah.
Yes? No? Okay. Up here at the top where it says insert, you see that? Boop. There's a little drop down that says table. And then these boxes show you how many boxes you're going to put in there. So I would put 4 boxes down and 1, 2, 3, 4, 5, 6 over. And that's going to give you a table where you can just fill in each of these data points if you want to do it that way. Okay? All right.
How many over? You said?
6. 1, 2, 3, 4, 5, 6. All right. Color for quartz. What do we have? It's like a milky white color. Silicon? Dark gray. And oxygen? Odor? Do you guys have an odor for quartz? Me? No? Okay. Silicon have an odor? Nope. How about oxygen?
It does.
Okay, well you're going to put your data in, okay? Because I want you to use your data in order to write your CER statement, okay? How about density? What's density of quartz? This is going to vary a little bit. Colton, what'd you get? Colton?
2.617.
Okay. Grams per milliliter?
Oh, wait, no, it's good. 2.61.
2 point what?
61.
Okay. How about silicon?
You didn't get that.
You didn't get that? I gave one to you on the sheet. Who's got the density for silicon?
2.3
Okay. How about the density of oxygen?
0.001.
Okay. Melting point, you guys can record your data in there if you want to. What's the melting point for silicon? Okay, how about for oxygen gas? 218? Okay. Okay, so now you've got some data, right? And now we need to connect our claim to our data. We need to connect our evidence and our claim together using reasoning. Okay?
What's that on the bottom? The dark gray and then
None? Yeah. Okay, so for each piece of evidence that you're planning on using, you should have some reasoning. Okay, so do we want to focus on a couple of changes here? What's the first thing that we need to do in order to answer this question? What do we need to define? What scientific principle do we need to pull in? Look at our question, guys. We need to define what a chemical change is, right? So a chemical change occurs when what? Okay? When two substances combine to form a new substance which has what? Different properties. Than the reactants, right? So chemical change occurs when two substances, we call those two substances reactants, combine to form a new substance. We call that the product, right? Okay, so here's our sciencey bits, right? That's the scientific principles that we're going to rely on to connect our evidence and our claim. All right, so we need to see if we have evidence that the substances that we started out with, or our reactants, have different properties than our product, right? So, do we need to use all of them? No. Do we need to use enough so that we have a substantial amount of evidence? Does that make sense? For sure. All right, so let's take a look at where we're going to start off with this. There are a couple of sentence starters back here, or like I said, you can use them on your digital interactive notebook. They're also there. We've got piece of evidence, so like blank piece of evidence supports the claim because, or the blank piece of evidence is connected to the claim because. So let's see how we could write those kind of sentences, okay? So what evidence are we going to start with? Let's start with the state. That's the first one, right? So, how could we word this evidence? We're just describing the evidence that we see here, right? Which says that. Good. So, reactants, oxygen, which is a gas, and what's our other reactant? Silicon, right? Which is a solid form quartz, which is a solid, right? We could say something like this supports our claim because the state of matter
Not public is selected.
okay, I've got a charger vector in the back. I'm gonna go back there. Yep.
On the reasoning section,
Mm-hmm.
what are the last?
Then they're reactants. Yep. Okay, so reactants oxygen, which is a gas, and silicon, which is a solid, form quartz, a solid. This supports our claim because the state of matter change shows that a chemical change has occurred, right? So the state of matter change, which is what type of what are we observing here? It's a change in property, right? So we're using our evidence. We're connecting it to our claim using some reasoning, right? So we have defined what it means to be a chemical change. We have identified what the reactants are and what the products are, right? So reactants oxygen and silicon are in two different states, and their product is quartz, and that is in a solid state. Since those two reactants have different properties, their state of matter is their property that we're talking about, then their product, which is quartz in a solid, we know that a chemical change must have happened, right? What's another piece of evidence that we can use? Color, okay? Do you guys think you can write that one on your own using this format?
Yeah.
Why don't you take a stab at it?
Wait, do you want us to like input down or just keep writing?
Like for a new paragraph? It's up to you. You can use new paragraph if you want to.
Or do we have to write all of that over here?
Yeah, except you're going to use color this time, right? So we're saying that our observation of color changing from milky white and dark gray to, from dark gray and clear and producing a product that has a milky white color, that color change is evidence that a chemical reaction has occurred, right? Because the properties of the reactant are different than the properties of the product. Does that make sense, guys? Okay, I just want you to you can use one more if you get real excited and you want some more practice. Go ahead and pick one more that you want to use. Okay, and then when you're done with that, go ahead and click turn in.